All right, welcome back. This is James Camp, your friendly computer science professor at Lee College in Baytown, Texas. And this is my introduction to Lesson 4, where we talk about decisions and Boolean logic. Now, computers, so far, when we've dealt with programs, we've dealt with programs that did one thing after another after another. But that's not always enough. In fact, it's quite often not enough. Frequently, we need to know, okay, we've got the user's name and age, and now we need to know, is the user old enough to buy alcohol in our online store, for example. So we'd need a decision. And we represent decisions in the flowchart with diamonds. So we might say greater than or equal to, let me get a little bit finer pen. We might ask if age is greater than or equal to 21. And if yes, we go ahead with the sale. And if no, we stop the program. Okay. That's a real simple decision, but it's a decision. And oftentimes programs are made up of several dozen of these decisions. But how does a computer make decisions? The answer is that a computer is a series of logic circuits. And one of the very basic logic circuits is one that can make a yes or no decision. And this logic circuit, which we'll just kind of represent as a little black box here, takes an input, and if that input is 1, then the logic circuit allows the input to pass right on through. If the input is 0, the output goes some other way. Okay, so we have essentially a true-false decision-making system here. In C++, we represent that in code by saying if, and in parentheses, we put some sort of condition that's going to evaluate to either 1 or 0. Okay, true or false. So in our simple example here, we'd say if age if age is greater than or equal to 21, then voila, we have our sale, else we end the program. Okay, ifs are often accompanied by else, which means do something different So if age is 21, we do this stuff, else we do this stuff. The last thing I want to talk about here is that we can have two things in our if condition here. We can actually have more than two things, but we have to combine them two at a time. We can combine them with ampersand characters. Okay. Or we can combine them with vertical bar characters. The ampersands mean and, the vertical lines mean or. Okay. We can say if something is red and hot, okay, then we're going to do some code, else we're not going to do that code, we're going to do something different. The and means both things have to be true, okay? You've got to have a 1 here and a 1 here. They've both got to be true, or the whole thing falls apart. What if I said if red and blue? Okay, we're going to assume that the same object can't be red and blue, so that would never be true. We would always just skip to the else, because if we had a 1 here, we'd have a 0 here. And if we had a 1 here, we'd have a 0 there, right? That's where the or becomes quite handy. If we said if red or blue, okay, then the object could be red, and we would do it, or the object could be blue, and we would do it. If it happens to be both, I'm not sure how that would work, but if it did, that would work too. It has to be neither red nor blue for us to fall through to the else. So something that's yellow isn't red or blue, so that would fall through to the else. Okay, and these these things are called Boolean logic. And that's where we get the word bool for the type. Red here would be a Boolean variable. Blue would be a Boolean variable. They would be storing a true or false value. Okay. So that wraps up my little explanation of computers and decision making. The simple idea is that whatever's inside this parentheses, okay, has to either evaluate to true or false. There's no in-betweens. It's either true or false. And these logic gates, if it's true, we do the green lines of code. If it's false, we do the red lines of code. Okay? So hopefully that gets you ready to think about all the intricacies of logic in C++. Go on with lesson 4. And as always, good luck and happy programming.